Alright, let's go ahead and do the data preprocessing. So we need to first import here train test split, and then we need to import here standard scalar. So I import here from sklearn.model selection, import train test split. Thereafter from sklearn.preprocessing, import standard scalar. Alright. Thereafter, we need to first train test split our input data and the target output, and thereafter we will also do here one hot encoding. In fact, before that we have to do one hot encoding. So why this one hot encoding is needed? There are many features which are actually a categorical feature. So for these categorical feature, we have to do here one hot encoding, because we need to change this categorical feature into a numerical feature. So it is very simple process. You need to just do it pd dot get dummies. We have done it many times previously. If you see there, now all these got converted. There are many features which got converted there. So there were 3 countries. We had Germany, we had France, we had the Spain there. Now we need to drop here one country out of these. Why? If we keep all these 3 together, then there is a multi-collinearity between these 3 columns. How? By keeping these 3 columns together, so I can predict one column by combining the value of the other 2 columns. It's always there. So how would you predict that? The prediction is very simple. If any one of these 2 columns is 1, then there is 100% guarantee that this column will be 0. You check that. When this is 1, then this is 0. When there is 1, 1, that's a 0. This is 1, this is 0. So whenever any of these 2 columns is 1, then it's guaranteed that it will be 0. And when both of these are 0, then there is always guarantee that it will be 1. So it creates a problem of the multi-collinearity. And similarly, this one is also creating a multi-collinearity problem. Whenever this is 1, then it's always, this is 0. Whenever this is 0, then it is always 1. So we need to drop a column there. So I do here drop first equal to true. If I do like that, then one column will be dropped there. Now we have just 2 country and just 1 gender there. Now this will be placed into x1 hot. So I see this one as the x1 hot. Thereafter I need to do here train test split. It's again a regular process. I do here x train, x test, and then I do here y train, and then y test is equal to train test split. In that I pass here x and the y, and then I pass here the test size, which is 0.2. Thereafter I pass here the random state as usual, which is the 42, and then I pass here the another thing, which is the stratify. So I'm gonna stratify our train test split with the y. So this stratify makes sure that whatever the split happens here, so in same amount, or you can say in the same ratio, the labels, unique labels in the output variable will be placed into the train and test the test data. Once this is done, now we have our x train and the x test there. Alright, so this is the train data. In the train data we have 8000 rows, and in the test data we have 2000 rows. So there were total 10,000 rows in our data. Alright, so out of 10,000, 8,000 rows is available for training and 2,000 rows is available for the testing. Now I see that in our x train and the x test, if you see there, these variables, in fact here one thing I got here that got missed out. I need to use here one hot. Alright, since x is categorical data, if I use one hot, then that will be one hot encoded data. So the one problem is here, these data, if you see here with the describe, alright, if you see it with the describe, and if you see this mean value, now you see the scale of the data is varying a lot. So all these data are not into the same scale. We need to bring back all these data into the same scale. So to bring that data in the same scale, I apply here a standard scalar. So I write here a scalar is equal to standard scalar. Again, this is usual process. We have done this 1000 times in previous lectures. So xtrain is equal to the scalar dot fit underscore transform, and then you pass here xtrain. Thereafter you pass here xtest is equal to the scalar dot transform. So this we have done many times. So what is this doing here? This xtrain is actually doing a fit and the transform, and the test data is doing just a transform. So whatever the learning is done on the trained data, that is being used on the test data. That's all it is being used here. Alright, so I just run it. Now we have our data, trained data and the test data. Now we need to build neural network. Now once we make neural network, thereafter we can start training our model. Alright, I'll see you in next lesson.